Although there exist several parameters to determine air quality, but only three, i.e., SO, NO, and SPM equals suspended particulate matter, are used. These give fair idea of load of pollution carried by the air. NERI has collected data from 10 Indian cities metropolitans such as Delhi, Kanpur, Calcutta, Nagpur, Hyderabad, Madras, Cochin, Bombay, Ahmedabad and Jaipur to assess the extent and nature of degradation of air quality due to industrialization and urbanization. Each of these 10 Indian cities was surveyed for residential, commercial, and industrial situations. In residential and industrial areas of Ahmed, lowest in Madras and Bombay coast, much above the international level. Residents of Delhi are exposed to some of the highest levels of air pollution in the country and perhaps the world. Methods of detection and measurement of air pollution. Air pollution is usually measured by sampling of air by thermal and by electrostatic precipitation, sunken impactor and electrostatic dust collectors. The particulate pollution is measured by the instrument called deposit gauge or by Owen's dust counter. The thickness of the smoke is measured by leading sphere and by Ringelmann chart. The rough estimation of SO in air can be made by chemical analysis of the dust collected in a deposit gauge or by a bubbler method. Fluorides are estimated by color reactions. Sources of air pollution. 1. Air pollution by natural means. Nature adds few natural pollutants such as pollen, hydrocarbons released by vegetation, dusts from deserts, storms, and volcanic activity. Thus, volcanic eruptions may eject large amounts of gases and particulate matter. Thus, when due to some natural processes or human activities the amount of solid waste or concentration of gases other than O increase in the air which normally has constant percentage of different gases in it, the air is said to be polluted and this phenomenon is referred to as air or atmospheric pollution. Air pollution is one of the most dangerous and thus, volcanic eruptions may eject large amounts of gases and particulate matter. Settling volcanic ash can kill vegetation by coating leaves and preventing photosynthesis and transpiration, e.g., following the 1980 eruption of Mt. St. Helens, USA. Fine particles, mainly of sulfates, may penetrate the stratosphere, spread widely and reflect significant amounts of solar radiation, leading to climatic cooling, e.g., the 1991 eruption of Mt. Pinatubo, Philippines. Likewise, dust storms sometimes carry fine sand for thousands of kilometers and favorable weather conditions stimulate the release of pollen, affecting people sensitive to it. 2. Air pollution by human activities. Industrial chimney wastes. There are a number of industries which are potent sources of air pollution. Petroleum refineries are the major sources of gaseous pollutants, e.g., SO, NO _, etc. Mathura-based petroleum refinery has been accused to aggravate the pollution-related decay of Taj Mahal in Agra and other historical monuments of Fatehpur Sikri complex. Industrial processors such as metallurgical plants and smelters, chemical plants, petroleum refineries, pulp and paper mills, sugar mills, cotton mills, and synthetic rubber manufacturing plants are responsible for about 1/5 of the air pollution. Cement factories emit plenty of dust, which is potential health hazard. Stone crushers and hot mix plants also create a menace. The SPM levels in such stone crushing areas are found to be 5 times the industrial safety limits. Chemical manufacturing industries emit acid vapors in air. B. Thermal power stations. The coal consumption of thermal power stations of India, e.g., Delhi has 3 thermal power stations, one at Indraprastha Estate, others at Rajghat and Badarpur, is several million tons. The chief pollutants of coal burning are fly ash, SO, and other gases, CO, NO, aldehydes and hydrocarbons, Chaudhary, 1982. C. Automobiles. The transportation industry exclusive of automobiles and including railroads, ships, aircrafts, trucks, buses, tractors, etc., contribute the same type of pollutants as cars, C. Smith, 1977. The vehicular exhausts are toxic being a source of considerable air pollution, next only to thermal power plants. The ever-increasing vehicular traffic density poses continued threat to the surrounding air quality. At the global level, there are over 300 million cars, trucks and buses and their number is increasing rapidly. India too has millions of vehicles, of which more than 65% are two-wheelers operating on petrol. The sources of emission in the automobiles are I. Exhaust system, E. Fuel tank and carburetor and E. Crankcase, figure 14.1. The exhaust produces many air pollutants including unburnt hydrocarbons, Colorado, NO, and lead oxides. There are also traces of aldehydes, esters, ethers, peroxides and ketones, these are chemically active and combine to form fuel tank. Smog in presence of light. Hydrocarbons, RCl, LCR, RTTT, smiley face S. Due to volatile nature of 1M. Petrol, evaporation from fuel tank goes on constantly and results in emission of hydrocarbons. The evaporation through carburetor occurs when engine is stopped and heat builds up in as much exhaust as 12 to 40 milliliters of fuel petrol hydrocarbons. Diesel is lost during each carbon monoxide. Long stop causing emission oxides of nitrogen, of hydrocarbons, some gas particulates, other gases tires. Vapor escapes between particulates. Gases degree. Walls in the piston, which figure 14.1. Hydrocarbons and other particulate and gaseous emissions enters the crankcase and then from automobile discharges into the atmosphere. Thus, the total hydrocarbon emission of an engine reaches up to 25%. Other sources of air pollution are minor in quantities but bear significance due to the harmful substances they release. These are agriculture, which is responsible for pesticides, dust from agriculture practices and field burning, and the construction industry. Types of air pollutants. All the just described sources of air pollution release the following air pollutants. 1. Carbon compounds, e.g., Colorado, Colorado. 2. Sulfur compounds, e.g., SO, H, S and H, SO. 3. Nitrogen oxides, e.g., NO, NO, and HNO. 4. ozone, O, 5, fluorocarbons, 6, hydrocarbons e.g., benzene, benzopyrene, etc., 7, metals e.g., lead, nickel, arsenic, beryllium, tin, vanadium, titanium, cadmium, etc., 8, photochemical products e.g., olefins, aldehydes, photochemical smog, PAN, PB, N, etc., 9, particulate matter e.g., fly ash, dust, grattan SPM, and 10, toxicants. Some of the most common air pollutants, their sources and their effects on human health have been tabulated in Table 14:1. Common air pollutants, their sources and pathological effects on man. JELICREDB, source, Southwick, 1976. Pollutants where they come from, source pathological effect on man 1. Aldehydes thermal decomposition of irritate nasal and respiratory. Fats, oil, or glycerol. Tracts. 2. Ammonious chemical processes, die-inflame upper respiratory. Making, explosives, lacquer, fertilizer. Passages. 3. Arsenes processes involving metals break down red cells in blood. Or acids containing arsenic soldering. Damage kidneys, cause jaundice. 4. Carbon gasoline motor exhausts, reduce oxygen carrying monoxides burning of coal. Capacity of blood. 5. Chlorines bleaching cotton and flour, attack entire respiratory tract many other chemical processes. And mucous membranes of eyes. Cause pulmonary edema. 6. Hydrogen fumigation, blast furnaces, interfere with nerve cells, cyanides chemical manufacturing, produce dry throat, indistinct. Metal plating, fission, headache. 7. Hydrogen petroleum refining, glass irritate and corrode all body fluorides etching, aluminium and fertilizer passages. Production. 8. Hydrogen refineries and chemical smell like rotten eggs, cause sulfides industries, bituminous fuels. Nausea, irritate eyes and throat. 9. Nitrogen motor vehicle exhausts, inhibit cilia action so that oxides soft coal. Soot and dust penetrate far into the lungs. 10. Phosgenes chemical and dye manufacturing. Induce coughing, irritation, and carbonyl sometimes fatal pulmonary edema. Chloride, cocal. 11. Sulfur coal and oil combustion. Cause chest constriction, headache, vomiting, and death from respiratory ailments. 12. Suspended incinerators, almost any type of cause emphysema, eye irritations particles manufacturing. And possibly cancer. Ash, soot, smoke. Ecology of air pollution. Once injected into the atmosphere, pollutants enter the biogeochemical cycles by different routes. The air above many cities can assimilate and disperse great quantities of fine particulate and gaseous pollutants as long as air can move and disperse, figure 14.2. But if air masses over cities, meteorological factors affect the distribution of pollutants. L underscore. Become stagnant, Pollet underscore L. OY, equals, ants accumulate quickly. And deterri, or rate I, R qual equals, S1 inch HI equals, underscore. Dot, underscore equals R, 3I, G which water vapors. A, gaseous pollutants. 1. Sulfur oxides and hydrogen sulfide. One. Sulfur oxides and hydrogen sulfide. These gaseous pollutants are naturally released by the biological decomposition and from volcanic eruptions. They are also released artificially due to human activities such as smelting of sulfide-containing ores, combustion of sulfur-containing fuels such as coal and oil, petroleum refining and obtaining of geothermal energy. According to a report, the sulfur dioxide (SO) content of the atmosphere in Delhi City has reached the level of 0.233 ppm, whereas in USA and West Germany the permissible limit is only 0.1 and 0.05 ppm. Concentrations as low as 0.3 ppm may damage plants. Lichens are particularly sensitive to SO, and in polluted regions one does not find lichens growing on the tree trunks. Thus, lower quantities of sulfur dioxide suppresses the overall vegetative as well as reproductive growth and yield. Its high atmospheric concentrations produce various injuries to leaves such as interveinal and blade damage, necrosis of leaves and cellular collapse, figure 14.4. However, moderate SO pollution results in chlorosis of leaves without cellular collapse. Pine trees are more susceptible than broadleaf trees and react by partial defoliation and reduced growth. Plants exposure to hydrogen sulfide results in leaf lesions, mottling, defoliation and reduced growth. Sulfur dioxide pollution causes in human beings various types of injuries such as eye irritation, chest constriction, headache, vomiting and death from respiratory ailment. Figure 14.5. It paralyzes or destroys bronchial cilia in air passages of man, constricts bronchi, damages lungs, lowers resistance to pneumonia and influenza and causes bronchitis, emphysema and irritation of the mucous membranes, i.e., an increase in cough and sputum. In fact, so, and other pollutants bring about coalescence of alveoli, figure 14.6, and reduce the amount of surface area available for the transport of oxygen and also reduce the rate at which air is exchanged. When there occurs severe pollution of SO, the death rate in bronchial asthma are found to increase, and in past it caused such disasters as Muse sulfur ozone dioxide flecking, intervenal, and blade damage. C.U.D. Panner. Valley in Belgium in 1930, Denora, in 1938, London, in 1952, and New White Work in Tokyo in 1960s, see Southwick, 1976. Further, in the atmosphere, SO does not remain in the gaseous state for a long time, but very soon it reacts with moisture to form sulfuric acid or H, SO. Sulfuric acid causes many respiratory diseases in man and also produces acid rainfalls over parts of the earth. In Scandinavia, downwind. L. Dizziness. Equals, headache. I. Irritation. E. Nasal irritation, coughing. Equals, and. L. Shortness of breath. I. Trademark. Sore throat. LL. Equals possible lung, cancer and B. Other lung eye diseases. Dot. 1L. GU chest pains. 1I increased. I. B. Cold allergies. N. U. Exclamation mark. A4. O. Figure 14.5. Ailments caused in man by air pollution. From the industrial centers of Britain and the Ruhr Valley, the acidity of the rainfall has increased 200-fold since 1966, with pH values as low as 2.8 being recorded. Odin et al., 1970. This acid rainwater has increased the acidity of Scandinavian streams, interfering with salmon reproduction and destroying salmon's runs. It has reduced forest growth and increased the amount of calcium and other nutrients leached from agricultural soil. The acid rainfall is also involved in the erosion of building materials as limestone marble, the slate used in roofing, mortar and deterioration of statues. 2. Carbon monoxide. It is released chiefly from gasoline engines and burning of coal in the defective furnaces. In man, county produces headache, dizziness, inability to distinguish time intervals, nausea, ringing in the ears, heart palpitation, pressure in chest and difficulty in breathing. This gas combines with hemoglobin of blood to form carboxyhemoglobin in RBC, which reduces its oxygen carrying capacity to all parts of body and, thus, causing asphyxia. The higher concentrations of carbon monoxide, CO, may be even fatal. CO and nicotine from the cigarette smoke increase the tendency for the blood to clot and so block the coronary arteries. Carbon monoxide also increases the rate at which the fatty materials are deposited in the arteries. 3. Nitrogen oxides. The natural sources of this pollutant are anaerobic bacterial breakdown of nitrogenous compounds, forest fires and lightning. Its chief anthropogenic sources are power generators and automobile exhausts, motor vehicles. Burning of organic wastes, and manufacture of explosives and nitrogenous fertilizers further add to nitrogen oxide pollution. Nitrogen dioxide, NO, a pungent gas that produces a brownish haze, causes nose and eye irritations and pulmonary discomfort in men. It also produces general and pulmonary edema and hemorrhage. In plants, NO brings about bifacial necrosis leading to collapse of leaves, enhancement of green color followed by chlorosis and extensive leaf drop. Ultimately there occur an increase in fruit drop and decrease in fruit crop. Photochemical smog. In the atmosphere, nitrogen dioxide is reduced by ultraviolet light to nitrogen monoxide and atomic oxygen. No plus O atomic oxygen reacts with oxygen to form ozone. Acid deposition of corrosive. This limestone statue at Reims Cathedral in France is being dissolved away by acid deposition. Constriction alveoli. Normal. Affected by pollution. Figure 15.6. Effect of sulfur dioxide and other air pollutants on the bronchial tubes of human lungs. 0 plus OO. Ozone reacts with nitrogen monoxide to form nitrogen dioxide and oxygen, thus closing the cycle. NO plus O, greater than NO plus 0. Sometimes, in the presence of sunlight. Atomic oxygen from the photochemical reduction of NO also reacts with a number of reactive hydrocarbons such as methane, ethane, toluene, etc., all of which originate from burning of fossil fuels or directly from plants to form reactive intermediates called radicals. These radicals then take part in a series of reactions to form still more radicals that combine with oxygen, hydrocarbons, and NO. As a result, nitrogen dioxide is regenerated, nitric oxide disappears, ozone accumulates, and a number of secondary pollutants are formed such as formaldehyde, aldehydes, and peroxyacetyl nitrite or PAN, CHON. All of these collectively form photochemical smog. Ozone, PAN, and nitrogen dioxide severely injure many forms of plant life, destroying the cells of leaves, damaging the chloroplasts, and interfering with the plant's metabolic processes. PAN is known to block Hill reaction of photosynthesis. It results in bronzing and glazing of a baxial leaf surface, figure 14.4d, which is due to plasmolysis and collapse of mesophyll cells around substomatal chambers, figure 14.8b. Epidermal and guard cells are not injured by PAN. 4. Ozone. Levels of ozone O may rise in atmosphere due to human activities. It is also formed by NO under UV radiation's effect. Minor amounts of ozone are also added to the atmosphere by electric discharges GH, such as lightning J, Q, flashes, by vertical flux of stratospheric ozone and by tropospheric storms. Sulfur dioxide. Soot particles, carbon dioxide, carbon monoxide, nitrogen oxides. Cold aerosolene fumes. Ozone near the Earth's surface in the troposphere creates pollution problem. Increase in O concentration of Earth's surface is toxic to plants, reducing crop yields significantly. Also has adverse effects on human health. See table 14-2. Thus, while higher levels of O in the atmosphere protects us, it is harmful when it comes in direct contact with us and plants at Earth's surface. If 10 OBV 0 effects of ozone 003 on human health. E figure 14.7. Formation of the smog and its climatic effects. Concentration ppm. Effects observed 0.2 no ill effects 0.3 nose and throat irritation 1.0 - 3.0 extreme fatigue after 2 hours. 9.0 severe pulmonary edema. Implants, enter through stomata and produces visible damage to leaves and results in decrease in yield and quality of plant products. Thus, results in necrotic flecking of upper surface of leaf, figure 14.4c, general chlorosis and bronzing, premature senescence of plants, precocious dropping of older leaves, reduced growth of shoots and plasmolysis and oops, supras, scion of SMHS, NKPA FFYLLLOCF skullpap is reeno CFHYSMPOW NGY. Nodulation, reduction in seed set and yield, ozone causes shrinkage of nuclei and cytoplasm or mesophyll cells, which become granular and results in increased intercellular space Fig. 14.8a at 0.02. Figure 14.8. A. Affect of ozone on the palisade layer of leaf. B. Collapse of spongy parenchyma in the region of substomatal cavity due to pan. ppm. Damages tobacco, tomato, bean, pine and other plants. It is now known to be the cause of several widespread diseases of plants such as weather fleck of tobacco, leaf tip burn of carnations, tip burn of onions, bronzing of bean, speckle leaf of potato and brown leaf of grapes. In human beings, audience 9.0 ppm concentration result in severe damage of pulmonary organs. Its lower concentrations result in nose and throat irritation and severe tired feeling. See table 14-2. 5. Fluorocarbons, hydrogen fluoride. Natural sources of fluorides in the atmosphere are active volcanoes. Their man-made or artificial sources are petroleum refining, aluminium, steel and electrochemical reduction plants, blast furnaces, brick kilns, and tile, glass etching and superphosphate fertilizer industries and combustion of coal. Fluoride burns the tip of plant leaves, figure 14.4b. Its low amounts impair plant growth, result in excessive dropping of bloom and young fruits, development of small, partially or completely seedless fruits and premature formation of soft red flesh and splitting of peach. In human being, it irritates and corrode all body passages. 6. Hydrocarbons. Biological decomposition of organic matter, spill and seepage from natural gas and oil fields and volatile emissions from plants are some major natural causes for the release of hydrocarbons such as methane, terpenes, ethylene and aniline. Incomplete combustion of fuels, automobile exhaust figure 14.1, petroleum refineries, agricultural burning, motor fuel marketing, manufacture of explosives and cracking of natural gas in petrochemical plants, as blow-off emissions constitute the man-made sources that emit hydrocarbons. The hydrocarbon ethylene causes yellowing and occasional necrosis of leaves, chlorosis of floral buds, inhibition of terminal growth, epinasty of leaves, shortening of internodes, thickening of stems, lack of apical dominance, stunted growth, dry sepal, disease of orchids and decrease in the amount of chlorophyll and carotenoids. Another hydrocarbon aniline results in the alveoli appearance of bands on leaves as if they are water-soaked. Necrotic spots and abscission of leaves. In man, hydrocarbons bring about irritation of mucous membrane, bronchial constriction and eye irritation. One of the hydrocarbons released due to incomplete combustion is 3,4-benzpyrene, which is said to cause lung cancer. Methyl isocyanate gas, when accidentally leaked out from the storage tanks of the pesticide factory in Bhopal on December 2, 1984, had killed over 3,000 persons and seriously affecting lakhs of residents. 7. Hydrogen chloride. This pollutant is released from combustion of coal, paper, plastics, chlorinated hydrocarbons, accidental spills from the chemical manufacturing plants and ignition of solid fuel rocket engines in plants. Hydrogen chloride causes plasmolysis and collapse of epidermal cells of leaves and thereby results in abaxial glazing of leaves. 8. Ammonia. The main anthropogenic sources of this gaseous pollutant are refrigerator, pre-cooler systems of cold storages, manufacture of dyes, explosives, lacquers, varnishes, and anhydrous ammonium fertilizers and nitric acids and domestic incineration. Ammonia causes in plants bleaching of figure 14.9. A. The appearance of alveoli leaves, rusty spots on leaves and flowers, reduction of ruben of a normal lung. B. The shoot growth, browning and softening of fruits, development of appearance of alveoli in the dark, corky lenticels in apples, and reduction in the rate of seed lung of the person suffering germination. In man, it inflames upper respiratory passages with emphysema. 9. Tobacco smoke. Tobacco smoke contains about 300 chemical compounds including nicotine and carcinogens such as tar, aromatic hydrocarbon. It is mainly produced by smoking cigarettes and bidis. It is gradually becoming a pollutant especially in closed atmospheres such as buses, trains, auditoria, discotheques and so on. Nicotine stimulates some types of synapse of nervous system, increased blood pressure and heart rate by the production of adrenaline, causes vasodilation in the muscles and vasoconstriction in the skin. When a person smokes, tiny particles in the smoke get caught on the lining of the windpipe and bronchial tubes. Extra mucus is produced and the cilia stop beating. The mucus collects in the bronchial tube and this gives rise to a smoker's cough. Repeated coughing may cause the delicate walls of the alveoli to break down into larger spaces. This cuts down the surface area over which gaseous exchange can take place, so the person gets very short of breath. Doctors call this condition emphysema, figure 14.9. Tobacco smoke also brings about thickening of bronchial epithelial layer, loss of ciliated cells and appearance of cells with bizarre nuclei, which are probably the precursors of cancerous cells, figure 14.10. Although smoking mainly affects the lungs, it can also cause cancer of other organs such as mouth, throat, esophagus and bladder. It is also associated with heart disease and stomach ulcers, and a woman who smokes while she is pregnant is more likely to have spontaneous abortion of stillbirth or to give birth to an undersized baby. See ill, Eoscus mouse epithelium asterisk. B. Particulate pollutants. 1. Fluorides. The particulate fluorides originate in the same way as the gaseous fluorides. They settle and accumulate on the grass and other vegetation. They are less toxic to these plants, causing occasional leaf burns. However, ingestion by cattle of various fluorine compounds falling on forage causes fluorosis, a disease characterized by abnormal calcification of bones and teeth, eventually resulting in loss of teeth, body weight and in lameness. Fluoride pollution in man and animals is mainly through water. In our country, fluorosis is a public health problem in states of Gujarat, Rajasthan, Punjab, Haryana, UP, Andhra Pradesh, Tamil Nadu, Karnataka, and some areas of Delhi. Globally, it is a problem of various other countries such as USA, Italy, Holland, France, Germany, Spain, Switzerland, China, Japan and some African and Latin American countries. 2. Lead. Lead, a heavy metal, is injected in the atmosphere mainly from automobile exhaust. Automobile gasoline contains tetraethyl lead that is used as an anti-knock additive. Lead is emitted into the air with the exhaust as volatile lead halides, bromides and chlorides. About 75% of lead burnt in gasoline comes out as lead halides through tailpipe in exhaust gases. Of this, about 40% settles immediately on the ground and the rest, 60%, goes into air. That is why its concentration is higher in urban areas where automotive and industrial exhausts are more, figure 14.11. Further, the use of lead-lined vessels for cook-harmful ing and the storage of wine resulted in heavy lead concentration. Burdens in the bodies of Roman citizens. Some have tilde rural urban attributed the decline of the Roman Empire to chronic pound GG population population. Lead poisoning. In fact, analysis of bones, of Roman 2 equals. Citizens have revealed high lead concentrations, C 840. Kimball, 1975. Lead pollution is also caused by percent. Occupational manipulation of putty and paints by equals 20 painters, habitual or accidental nibbling of peelsifold and paints, smelting complexes, ceramics, pesticide sand equals 0% for trademark 05-53040506 solder used for sealing. The lead level of air and air lead concentration parts per million quality guide of WHO is 2 pg per meter. This level is already crossed in many Indian cities and in various countries, figure 14.11. Comparative accumulation of lead in the tissues of rural and urban off-world. For example, in Kanpur and Ahmedabad, lead level vary between 1.05 to 8.3 pg per meter and 0.59 to 11.38 pg m3, respectively. Roadside plants and meadow mice living along major highways are found to contain high concentrations of lead in tissues, and this has a sublethal effect on the health and longevity of the animal. Traffic policemen and others who are exposed for long periods to heavy traffic have higher than average lead in their blood and body tissues. High lead accumulation in the tissues of human body interferes with development and maturation of erythrocytes, RBC, and causes anemia. Even 0.2 parts per million, 0.2 ppm, concentration of lead in human body creates metabolic disturbances. Chronic exposure to lead leads to stippled red blood cells having impaired capacity for oxygen transportation. Being a cumulative poison, it disrupts the functioning of cells and organs of the muscular, circulatory and nervous systems binding with the cellular enzymes and coagulating proteins, thereby, results in nausea, weakness and dizziness. It also damages liver, kidney and gastrointestine and induces abnormalities in fertility and pregnancy. 3. Mercury. It is a liquid volatile heavy metal which is found in rocks and soil. It is present in air due to human activities such as the use of mercury compounds in production of fungicides, paints, cosmetics, paper pulp, etc. Inhalation of 1 mg per meter of mercury in air for 3 months may lead to human death. Nervous system, liver and eyes are damaged. Infant may be deformed. Other symptoms of mercury toxicity are headache, fatigue, anxiety, lethargy, loss of appetite, etc. 4. Zinc. Zinc in air occurs mostly as white zinc oxide fumes and is toxic to man. It exists in air around zinc smelters and scrap zinc refineries. 5. Cadmium. This metal is emitted to air by human activities and industries, e.g., electroplating and welding of cadmium-containing materials, industries producing pesticides and phosphate fertilizers. Cadmium occurs in the air in the form of oxide, sulfate or chloride compounds. It is poisonous at very low levels and is known to accumulate in human liver and kidney. Cadmium causes hypertension, emphysema and kidney damage. It may also act as carcinogen in mammals. 6. Potassium salts. These particulate pollutants are derived mainly from potash mines and cause in plants abnormalities such as branch tip death, chlorosis and necrosis of leaves. 7. Sodium chloride. Certain de-icing salts such as sodium chloride, used to remove ice and snow from roads in winters, are found to cause multiple damage to the roadside trees such as leaf necrosis, defoliation, suppression of flowering, and dieback of terminal shoots in apple. 8. Agricultural chemicals. Several types of chemicals such as insecticides, herbicides, fungicides and pesticides, used widely in agriculture are found to result in foliar lesions, chlorosis and abscission of leaves and reduction in fruit set. 9. Particulate matter. The word particulate has been derived from particle and includes all solid or liquid substances primarily in the air. Particulate matter is usually divided into 2 categories, suspended particulates and dust fall. Suspended particulates. These are smaller than 10 microns. They are generated by various industrial processes, combustion processes and black soot. In polluted air, their concentration may reach up to 100,000 per cc. B. Dust fall. Dust fall includes the particles larger than about 10 microns. They are emitted into the air by physical processes such as grinding and abrasion, a soot and fly ash or PFA equals pulverized fly ash from fuel combustion. Dust particles settle at the ground quickly and cause nuisance to certain industries requiring aseptic conditions such as drug industries and food processing plants. The average level of dust and particulate matter in Delhi is about 600 milligrams per meter. In Bombay about 200 milligrams per meter. In Calcutta about 300 milligrams per cubic meter, whereas it is just 150 milligrams per meter. In other polluted western cities, dust may be inorganic and organic in nature. 1. Inorganic dust containing silica and trapped heavy metals is the main pollutant in mining, quarrying and stone cutting operations. 2. Organic dust raised in cotton textile mills, ginning plants, quarrying and processing, jute and hemp processing, sawmills and plywood industries are also potentially toxic with properties of sensitization of persons exposed to them. Particulates emitted from cement manufacturing units cause in plants premature fall of needles, higher puberty of leaves, formation of more stomata and trichomes, reduction in number and size of cobs and weight of seeds and increase in number of infertile seeds. Dust from stone crushers, lime kilns and slate making units is also hazardous to plants and human beings. Particles of asbestos that are released from factories can wear off brakes and gears of cars. Coal dust and asbestos have been found to cause in plants necrotic lesions, reduction in fruit sets and silicosis, asbestosis and lung cancer in human beings. The common dust particles sometimes become health hazards as they may lead to diseases such as allergic asthma, bronchitis, emphysema and even fibrosis of lungs. Pulverized fly ash PFA is getting accumulated in such large quantities particularly in areas where thermoelectric generators are installed that it has proved to be one of the major sources of solid wastes. Since it contains boron, its deposition by wind in agricultural tracts often results in deleterious effects. In fact, living organisms are rarely exposed to a single pollutant in nature. The influence of mixtures of pollutants is usually synergistic, i.e., greater than the additive effects of the different pollutants alone. C. Effects of air pollution on weather, climate, and atmospheric processes. At gross level, air pollution causes 2 worldwide problems: contamination of the upper atmosphere and the alteration of weather and climate. Air pollution also affects weather on a continental or global basis. Many gaseous pollutants and fine aerosols reach the upper atmosphere, where they have basic effects on the penetration and absorption of sunlight. Brody, 1973, and certain other modern environmental biologists feel that increasing particulate pollution may be reducing the amount of sunlight energy reaching the Earth's surface, thereby lowering solar radiation at the Earth's surface and producing a cooling effect on world climates which could ultimately trigger another ice age. In fact, Thomson, 1975, has reported a decrease in mean annual temperatures in the northern hemispheres and an increase in the North Polar ice cap. Greenhouse effect. Carbon dioxide is a natural constituent of the sunlight atmosphere, but its content warms. Earth's surface traction is increasing in the air with an alarming rate. A byproduct of the burning of fossil fuel, it is not Earth's necessarily a pollutant. Its atmosphere equals i.e. GS3 produces adverse physiological effects only at very high levels. It is estimated greenhouse gases trap that approximately 1 heat and reflect it back. Half of the CO input stays in the atmosphere and other greenhouse effect. Half of it is removed the energy from the sun is either transmitted, reflected or trapped by the oceans and by plants. The atmosphere energy radiated back into space is at longer wavelengths in the increased amount of C02 infrared region than the energy arriving from the sun, and the consequence is that more heat enters than can escape. Greenhouse gases CO, CH, nitrous oxides, CFCs together with water vapor in clouds contribute to the blanketing effect of the atmosphere. In atmosphere is found to increase the temperature of Earth. The spectral properties of CO in the atmosphere are such that it tends to prevent the long-wave radiations, i.e., infrared heat radiation, from Earth from escaping into outer space and deflect it back to Earth. The latter has an increased temperature at surface. Turcotte, Al. 1974. This phenomenon is called atmospheric effect. Lee, 1974, or greenhouse effect. See Southwick, 1976. Smith, 1977. The simultaneous cooling and heating effects 352 S of air pollution on Earth. 344 have increased Varia S. Bill. Scientists fear that increased level of CO. Many are along coasts. Simultaneously, along with carbon dioxide. Many are along coasts. Many are along coasts. Many are along coasts. 3. Nitrogen oxides. The natural sources of this pollutant are Scientists fear that increased level of CO. Many are along coasts. Simultaneously, along with carbon dioxide, man has been adding solid particles and droplets into the air which increase the albedo or shyness of the Earth. This should act contrary to the greenhouse effect, reduce the sunlight reaching the Earth and tend to lower the temperature of Earth. Peeling of ozone umbrella by CFMs. Certain fluorocarbon compounds which are called chlorofluoromethanes or CFMs or freon are Certain fluorocarbon compounds which are called chlorofluoromethanes or CFMs or freon are used as propellants in pressurized aerosol cans. They are inert in normal chemical and physical reactions, but they get accumulated in greater amounts at high altitudes and will increase the greenhouse effect and thereby increase the temperature of the Earth. Only a slight temperature rise would cause the polar ice caps to melt and to cause an enough rise in sea level submerging a number of major cities of the world, because trademark T.U. Warming incoming. Pipe. The jet engines of supersonic aircraft flying at high altitudes release nitrogen oxides, NO, which catalytically destroy ozone molecules. See Southwick, 1976. The jet engines of supersonic aircraft flying at high altitudes release nitrogen oxides, NO, which catalytically destroy ozone molecules. See Southwick, 1976. Figure 14.12. The control of air pollution. Most kinds of air pollutions can be controlled by modern technology, but the costs ultimately be borne by the public in the form of higher prices for manufactured goods, higher taxes, reduced profit margins in industry, and more restrictions on individual activities such as burning leaves and trash and use of automobiles. Following steps have to be taken to control pollution at source: prevention, as well as after the release of pollutants in the atmosphere. 1. Prevention and control of vehicular pollution. For controlling the air pollution because of vehicles, the following measures are adopted. Curbing the pollutant emission from vehicular exhaust. This type of control can be attained by I. Using new proportion of gasoline and air. 2. More exact timing of fuel feeding. 3. Using gas additives to improve combustion. 4. By injecting air into the exhaust to convert exhaust compounds into less toxic substances. And by 5. Correcting the engine design and/or fixing cessation device to improve combustion with the existing design. Complete elimination of 3 main pollutants, namely Colorado, NOx and hydrocarbons, can be attained by either updating the present design of engines or by making appropriate changes in devices for improving combustion. In recent years, IK Bharati of Mumbai has claimed to have devised a simple attachment, by the patent name reactor, to curb air pollution by motor vehicle. The reactor is fitted to the exhaust tailpipe and it converts carbon monoxide into oxygen. Various devices such as positive crankcase ventilation valve and catalytic converter have been developed in USA to reduce exhaust emissions by automobiles. B. Control of evaporation from fuel tank and carburetor. This can be performed by 1. Collection of vapors with activated charcoal when the engine is turned off. 2. Subjecting the gasoline in the tank to slight pressure to prevent the gas from evaporation. And 3. Developing low volatile gasoline that does not evaporate easily. C. Use of filters. Filters can be used to capture and recycle the escaped gases, hydrocarbons, from the engine, i.e., the gas vapors which escape between walls and the piston and reach the crankcase. 2. Prevention and control of industrial pollution. To check the air pollution by industrial and power plant chimney wastes, measures are taken for the removal of particulate matter and gaseous pollutants. In different industries, air pollution can be checked at various steps. Fig. 14.13. A. Removal of particulate matter. This process involves collection of particulate e.e. matter under the influence of different forces. 5. Dispersion e.a. by thereby moving them continuously out of the OLE gas stream. This step involves the use of equals following equipments. I. Cyclone collector. In this case, the 4 waste gas containing particles is subjected to L centrifugation. The suspended particles remnant move towards the wall of cyclone body and 3SL. I then to its bottom and finally are discarded out. The cyclone collectors can remove up to 70% of the particles. E. Electrostatic precipitators, ESPs. To remove the suspended particles from gas S equals stream, the electrical forces are applied with an alkylate on the chamber in the precipitator. The particles 1 become charged or ionized, and they are 1 source I attracted to charged electrodes and removed. ESPs can remove 99% of the particulate pollutants from the chimney exhaust. ESPs work very efficiently in power plants, paper mills, cement mills, carbon black plants, etc. Sometimes, high resistivity dust may make separation in an ESP difficult. To overcome this difficulty, fibric filters or beg filters are employed. Further, tall chimneys are used for vertical dispersion of air pollutants. B. Removal of gaseous pollutants. These are removed from the chimney exhaust by the following 3 methods. I. Wet systems. These are used as washing towers in which alkali fluids circulate continuously. This liquid reacts with soap to produce a precipitate. In gas scrubber, a fine spray of water can effectively separate many gases such as ammonia and sulfur dioxide. E. Dry systems. In this case, the gas pollutants are allowed to react with an absorbent under a dry phase. Absorbents such as dolomite, lime, SO, and limestone (SO) are placed in the way of the flowing gas SO. The process is cheap and does not involve any spray of water. E. Wet-dry systems. In these cases, water in the absorbent reacts with the acid components. The absorbent calcium hydroxide slurry is spread into the hot gas stream in the form of small droplets. Calcium reacts with SO, and the hot gases cause the water to evaporate simultaneously. The end product is a dry powder containing mostly fly ash and salts. Control of air pollution through law. In our country there have been several legislative measures both at state and central government levels to prevent and control different types of air pollutions. 1. Bengal Smoke Nuisance Act, 1905. 2. The Motor Vehicle Act, 1938. 3. The Gujarat Smoke Nuisance Act, 1953. 4. The Air Prevention and Control of Pollution Act, 1981. It was amended in 1987. I. COOLENG. B. Figure 14.1. Various possibilities to control